So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. Welcome to another physics lecture. So we were discussing section 1.7 energy, work and power, and we were about to discuss the sources of energy. Now there are two types of energy sources. One is known as the non-renewable resources and the other one is renewable resources. Non-renewable resources are those which deplete over time when used, and they cannot be replaced as these resources take hundreds and thousands, in fact millions of years to be created. These resources include fossil fuels such as coal, oil and natural gas, and they are formed from dead plants and animals buried under earth for millions of years. Energy in fossil fuels is chemical in nature, and when you burn them, that energy is released through chemical process. The main energy source, they are the main energy source around the world, but when you burn fossil fuels, it creates environmental problems such as air pollution as well as acid rain, because they create carbon dioxide and sulfur dioxide, and they also cause global warming as well. However, they are still one of the cheapest and easily available fuels around the world. Then we have nuclear fuels. If you don't want to burn fossil fuels, then the other option is using nuclear fuels such as uranium or any other radioactive metal. They can be used in a nuclear reactor to produce electricity, or in simple terms energy, through fission or fusion reaction, which you'll study in later on section nuclear physics. They do not produce carbon dioxide or sulfur dioxide, but they do produce radioactive byproducts which can stay in the environment for hundreds of years or even for 1,000 years, because these byproducts have a very long half-life. Means they take a lot of time to be they are not degradable easily. They take a lot of time and many years to be degraded. In case of an accident, if there is one, a very large areas such as half of the city or a whole city can be affected with radiation poisoning. So that is one of the biggest concerns of using nuclear energy. Then we have renewable energy sources. They are also known as green energy. These energy sources cannot be depleted or cannot be exhausted with usage over time. The first one among these is solar energy, or the energy from the sun. It can be used to heat water in homes and offices through solar panels. Solar panels are basically sheets of glass with copper piping behind them, so when the uh, heat from the sun enters those glass sheets, it strikes those metal pipes and heat the water that is traveling through them. It can be concentrated by use of a solar furnace to boil water or to cook something, and use the steam to turn a turbine of a generator and produce electricity. Alternatively, for homes and offices, as solar furnaces and solar farms need a very large area, so instead, for offices and inside cities, we use solar cells, which are most commonly known as solar panels. But the correct name for them is supposed to be solar cells. Solar panels can only be used to heat water, whereas for generating electricity we have solar cells. They can be used to turn sunlight into electricity through commonly processes and chemical process, and they are commonly used in homes, offices and satellites. Electricity generated by solar can be stored in batteries for later use. So solar power plants are becoming more and more common these days around the world. They can also be used to power electric cars, not cars, electric cars and electric vehicles in many places but the downside is that in many places at several locations such as colder countries, sunlight is not a reliable energy source. There are not enough sunshine hours, or the sunshine is not you can say concentrated enough due to cloud cover. Hence, setting up a solar farm or putting solar panels in such areas is not a very good idea, or not a very economical one at least. Next, we have wind energy. Wind turbines or windmills can be used to convert kinetic energy of moving wind into electrical energy through a mechanical process. Multiple windmills are built close together in form of a wind farm to produce electricity on large scale. These are usually set up on coastal areas because coastal areas have a lot of wind, high speed winds almost all the time. Wind turbines can be very noisy and are considered as unsightly by some. This is sometimes referred to as visual pollution. Not everyone likes to see a whole lot of wind farms. There have been some concerns regarding environmental damage, as best location for these farms is a coastal or an upland area, so environmentalists have concerns regarding birds that live in that habitat, etc. Then we have tidal or wave energy. This can be utilized in two forms. Basically, this refers to the kinetic energy of moving water. The energy produced by rise and fall of water in seas and oceans or rivers is used to drive turbines and generate electricity. However, this system is currently developed on prototype based or very small models. It is not yet available for large scale use. The application of this, which is available on large scale use, is known as HEP, hydroelectric power, where we build dams on rivers and then we use the dams to block the flow of water, to store it, and then we make the water, the whole flow of the river, pass through very you can say thin or concentrated gateways or spillways. When the water passes through those gateways, the flow of water is reduced, hence it has more energy, so that falling water is used to turn a turbine, and that turbine is connected with a generator. When the turbine moves, the generator moves and electricity is produced, which is then supplied to homes and offices. This method of electricity generation is very cheap. It is one of the cheapest forms, but it may destroy fauna found in that area, as marine life can be destroyed, and it also restricts shipping routes. Obviously, if you are building a dam on a river, you cannot allow ships to pass through that. construction of dam is also linked with flooding. Location is of great importance to tidal HEP power stations, and they cannot just be developed anywhere. You have to consider a lot of geologists and a lot of engineers, and you have to pick a location very precisely, otherwise the building of a dam would not produce as much electricity as you wanted, and that would be a failure. Then we have geothermal energy, that is basically the heat energy that is inside the earth due to molten rocks. Cold water is pumped down into hot rocks beneath earth, and it is forced back up as steam, which can be used to turn blades of a turbine and generate electricity. However, geothermal power stations can only be built on a few specific locations and not just anywhere. Then we have biofuels. And what are biofuels? Basically, these are fuels which are generated by fermenting biomass. What is biomass? Organic waste materials such as leftover crops, leftover food, parts of crops which are not edible, animal dung, etc. All of these are mixed together in large containers, and then there are some enzymes are added which speed up the fermentation process. And by decomposing those organic materials, the enzymes or the bacteria that are added, they are able to create methane gas, which is used for cooking. In fact, alcohol can also be produced through this procedure. Alcohol can be used as a liquid biofuel. Liquid biofuels are lead and sulfur free, whereas petrol, means the crude oil, always have traces of lead and sulfur, and they can replace fossil fuels such as petrol, but they produce far less energy per liter as compared to fossil fuels. This basically means that, let's suppose you have a car that goes 10 kilometers in 1 liter of petrol. Then if you put biofuel, liquid biofuel in it, it would give you something like 7 or 8 kilometers or maybe less. This is the meaning of they produce far less energy per liter as compared to fossil fuel. Biofuels are a good option on a small scale, but large scale production is not economically feasible because biofuels do not pack as much energy as the fossil fuels. Their hydrogen content is not that great. If a fuel has more hydrogen carbon, it would burn more easily, more rapidly, and it would produce more heat or more energy on combustion. It reduces landfill sites as your waste material are utilized to create fuel instead of dumping it. But they can cause explosions as biofuel or biogas is quite unstable. So these are the sources of energy, and here we have an example question from the past papers for sources of energy. One type of renewable energy source is shown. State the name of this renewable type of energy. As you can see, some hot rocks are shown, and then you are shown a shaft or a pipe is being used to send cold water down and then get hot water and steam upwards. There we only have one renewable energy source that uses the earth's molten core, that is geothermal energy. State what is meant by a renewable energy source which cannot or will not deplete over time. Figure is a block of power station. The 4 boxes represents different part of the power station. First box is labeled as boiler. After boiler, what you'll have a turbine, then you'll have like the boiler is going to produce steam is going to turn the turbine will be used to turn a generator, and then generator will produce electricity that would be given to a transformer for smooth distribution. And here are your guiding words: generator, motor, transformer, turbine, and solar panel. Now motor and solar panel have no use in a HEP station or in a power station, but generator, transformer, and turbine are of use to us. So we use the energy, we use boiler to heat water and produce steam that is used to turn the turbine. Then turbines When turbines are turned, it converts the heat energy of steam into mechanical energy, and then the turbines or that mechanical energy is used to move the generators, which convert that mechanical energy into electrical energy, and then that electrical energy is you can say smoothed out by the help of a transformer, so it can be supplied to houses and offices, etc. State 1 environmental problem caused by burning oil, air pollution, acid rain, global warming. You can state any one of these. Oil is a non-renewable energy source. State why oil is described as non-renewable, because the reservoirs of oil will deplete over time. State 1 renewable energy source. You can write any name of any one: solar, wind, thermal, tidal, HEP, biofuels, etc. Next we have power. Power is defined as the rate of work done per unit or energy converted per unit time. So power, the formula for power is given as W upon T, yani work done per unit time, or it can also be written as P equals to delta E, means change in energy divided by T, divided by time. SI unit for power is supposed to be watt. Capital W is the symbol. Large amounts of power may be represented using kW, kilowatt, or megawatt, MW. It is a scalar quantity, and if you remember our first topic, measurement in physical quantities, you would know that there are 1000 watts in 1 kilowatt and 1000 kilowatts in 1 megawatt. 1 watt is defined as the rate of work done or energy conversion of 1 joule per second. If you are converting 1 joule of energy from one form to another form in 1 second, then that is assumed to be 1 watt. So just remember this for questions related to power, that 1 joule is always equal to 1 watt. Power tells us how fast work is being done or how fast energy is being converted from one form to another. The higher power the power rating, the faster the energy conversion being that is taking place. In some questions, work done is not directly given, but rather force and velocity is mentioned. Hence power can be calculated as follows. Remember the formula: P is equals to W upon T, whereas work done can also be calculated as force into distance. So we plug that into in place of W, so we get the formula as P equals to force into distance upon time. Now distance upon time is supposed to be speed or velocity, so we can also say that power is equal to force into velocity or force into speed. This may come in handy in some of the questions. Now we have example question. There is a hydroelectric power station. Water from lake is used to produce electricity in the turbine house. State where state where the water has the least potential energy. Now remember that potential energy is relevant to the height. So in the figure over here, in the lake, the water will have the maximum potential energy, as this is at a certain height or a maximum height. Now when it comes down near the turbine house or at the end of the hill, it would have the least amount of potential energy, or almost zero potential energy, as all of that energy would be converted into kinetic energy. In 30 minutes, the water loses 5 into 10 power 9 joules of energy, and 4.5 into 10 to power 9 joules of electric energy is produced. Calculate in watts the electrical power output from the turbine house. Simply power is equals to delta E upon T, or work done upon time. Over here we are given values in form of energy, so we are going to utilize the formula delta E, or change in energy divided by time. Now how much is the change in energy? 0.5 into 10 to power 9. How we find that? Initial energy minus final energy. So sorry, the output is given. Yeah, sorry about that. we are just will only be concerned with the output, because power rating is the you can say the output produced by any system. So we are not we are simply going to use the energy rating that is being outputted. So 4.5 into 10 to power 9 divided by time. What is the time? 30 minutes. Now this is given in minutes, so we'll have to convert it into seconds, because the formula states energy convert per second or per unit time. So 30 multiplied by 60 would convert it into seconds, 1800 seconds. 4.5 raised to into 10 raised to power 9 divided by 30 into 60 means 1800 would give you 2.5 into 10 to power 6 watts, or you can say 2.5 megawatts, as 10 is to power 6 is supposed to be mega. Last, we have efficiency. The efficiency of a system is a measure of how well energy is transferred in a system, like how much percentage of the energy is being transferred from by a system. Always remember, when you convert energy from one form to another using either mechanical or electrical or any other means, then the system loses some percentage of the energy during conversion process. There is no device, no equipment that can 100% convert one energy form into another. There is always a power loss, there is always a loss of energy to the surrounding. So in order to find that how much percentage of the energy has been converted, we use something that is known as efficiency. The more efficient a system is, the more percentage of energy it can convert, and the less percentage of energy would be wasted by the system. Efficiency is defined as the ratio of useful power or energy transfer output from a system to its total power or energy input. If a system has high efficiency, this means most of energy transferred is useful, and if a system has low efficiency, this means most of energy transfer is wasted. Mostly power stations are about 30% efficient. That means that to boil water and then use that water to turn a turbine, and that use the turning of the turbine to run to move a generator and then produce electricity. That means if initially you invested 100 joules of energy into the process for heating the water, ultimately you are only going to get 30 joules or 30 watts of electricity from the powerhouse. Powerhouses or power stations are one of the most you can say inefficient systems in the world. Their efficiency is very low. Remember that. This might come in handy in some of the questions. So anyways, the formula for efficiency is energy output divided by energy input into 100%. Or in terms of power, you can write it as useful power input, or the power input divided by total power output into 100%. You always have to put a percentage symbol with your answer when talking about efficiency. Example question: a turbine wheel is used to generate electricity. Water enters at the top to turn the wheel, which rotates a generator connected to it and produces electricity. Here's the generator. The change in potential energy of water is 2000 joules per second. The electrical energy output is 1200 joules per second. Calculate the efficiency. Now you know the formula: input divided by total output into 100. Input is 2000 joules, output is 1200 joules, so 2000 divided by 1200 into 100% would give us 60%. That means this system is only 60% efficient. It is wasting 40% of power to the environment. That's it. That's all you need to know for section 1.7. I hope you have understood. If not, please do leave your comments and let me know if you have any issues. I'll see you guys in the next video. Take care. Allah Hafiz.